It's a new era of NAND. The layers race is over. A shift in focus is rewriting the future, creating opportunities, sparking innovation. Capacity, efficiency, performance. Western Digital is leading the way, building next-gen storage solutions, fueling growth across the entire data cycle. Welcome to the new era of NAND.
All right, I'm excited to share with you Western Digital's vision of the new era of NAND. We have a lot to share in terms of our view of the market evolution, where we sit and where we're headed. I'm also excited, and at WD we're excited about the impending separation of WD into two standalone publicly traded entities, a hard drive business as well as a flash business. We've been hard at work behind the scenes doing all of the regulatory work and the systems work to make that happen. If you're a customer or a partner, you should have already heard from us. And if not, reach out and make sure that we're connected as we go through this transition. It's a great opportunity for all of us, and we're excited about this renewed focus on the flash industry. So with that, let me jump in. So the title of our session is A New Era of NAND. I'm going to take you through really three sections here. The first is a little bit about the old era and why that old era is over. Then we'll talk about the new era, what it represents, and then we'll touch on our view of the AI data cycle, and you can compare and contrast the various speakers today. I'm going to be joined by some of our Western Digital VIPs. Adarsh Kannan. Adarsh is an economist. I think he's the only economist working in the flash industry, so I think you're going to be excited to hear what he has to say. Khurram Ismail, who leads all of systems development for WD, as well as Rizwan Ahmed, who leads our enterprise SSD efforts. So earlier this year, we went out and did a launch of this new era of NAND, and we said something pretty controversial, which is it's the end of the layers race. Now, how many people in this audience believe that? Go ahead. The WD team down here, you have to vote yes. All right. Okay, so I got a little work cut out for me in convincing you that that's true. But don't fret, there are going to be more layers. We're going to keep innovating. But this thing that we have in the industry thought of as a layers race is officially over. And I'll explain why that's happened. So I'll start where Inu-san started this morning, our partners from Kioxia, and look at what's happened in the NAND industry. So a lot of people focus on that 2023 downturn, when indeed the NAND industry lost a horrific amount of money. But if you take a step back and you look at a 10-year span of time, and you look at financial performance over those 10 years, it tells a story. So on the left side of this picture, purple, 2012 through 2018, average industry operating margins, almost 20%. On the right side of this picture, in that blue era, that sank to -5. Even if you take 2023 out of the picture, you can see the blue era is clearly below that purple era. And that was with the COVID demand bounce and all those crazy things that went on in that time. So you kind of got to ask yourself, like, well, what's causing this? What happened? In order to help answer that question, I'd like Adarsh Kannan to come on up. Adarsh?
Thank you, Rob.
Thanks, Adarsh.
Right, thank you for walking us down the memory lane.
Well done.
The only thing harder is to explain economics is to explain it in an afternoon session. So with that, when we study any industry, we want to try and understand the economics across two lenses, supply and demand. So you've outlined what happened to the operating income of the industry. So if we take a step back and understand the supply implication, here's a graph that shows clearly during the 2D era, we were spending, as an industry, something around $6 billion per year as capital. This is the conversion capital for 2D nodes.
So this was the entire industry in a single year would be spending $6 billion on conversion.
Exactly.
And to get some part of a node converted.
Exactly.
And that seems like actually, in kind of a small amount of money relative to what happened later.
That's where the story begins. So the moment we transition to the 3D era, that figure almost tripled. So in the 3D era, the industry started spending $17 billion per year. So that staggering figure, when it has a change in the supply side of the economics, is also going to impact the demand side of the economics, which is where the technology evolution, the bit cost reduction come into play.
Let me get ahead of you on the slides here, all right?
Yep. So in the 2D era, you could have a roughly parity for cost reduction and the bit growth. So 27% gen-to-gen bit growth rate paired with like 24% cost reduction. To steal your analogy there, that's where you could actually do this magic in the demand side, where you could go to the customer and convince them to buy a 256 gig phone for the price of 128.
That's a pretty good deal.
I would take it.
I would go for that, yeah.
Exactly. Intuitively, it makes sense for all of us who have experienced purchasing electronics. And the moment we move into the 3D era, we're seeing 40% bit growth, but only 11% cost reduction. So that demand implication is that you go to the store, you want to buy a 512 gig phone, but you're going to get 1.5, 1.6 times the price of a 256 gig phone.
Yeah, that's kind of a problem because that 512 gig phone sat in a specific price lane. The 256 gig phone was in its price lane. Now I'm not offering the same kind of incentive.
Exactly what customers felt as well. So to us, the incentive structure is a writing on the wall, which is earlier we could pick layers as this myopic vector where we could induce bit growth through price reduction, and the price response in the market would enable us to do it. In the new era of NAND, the key word is end of the layers race. We are not going to be able to pick that vector and just use layers as one means by which we create a bit growth and induce growth into the market using a price response.
So in my view, is anybody who is active in the NAND industry needs to fundamentally understand these numbers. The great thing about them is you can actually extract them from analyst reports, from market reports. You don't have to use any confidential information. But if you look at that number in that 3D era, 39% bit growth for 11% cost reduction. When you have that piece of information, now you can think about things like what growth rate do I expect? What cost reduction can I pass on to the market? How much capital should I invest? And you can start to do the math, which in my role, I need to spend a few $1 billion a year investing in capital in the NAND industry. That's a super important piece of math to understand.
Absolutely. Well, are we then going to stop producing more layers? Absolutely not. We're definitely going to, innovate, but that innovation is going to span across different vectors. It's not just layers. And there is this whole era of AI, which is going to create a whole new demand dynamics. That is going to create a different set of incentives. But the old era of NAND and the end of the layers race is here.
And I think it's not surprising. This essentially has already happened in DRAM and logic. Some of the earlier speakers today talked about it. In logic, we got to about 10 nanometers. Essentially, the cost curve inflected, where you're paying a premium to go to advanced nodes. In DRAM, 2011, 2012, right? DRAM, 6 generations trying to get from 20 nanometers to 10 nanometers. So really running up against that. The different thing about NAND is we've been able to achieve bit growth using this vertical scaling, because it's pretty straightforward. You just buy a lot more capital and you can scale. That bit growth, though, just did not come with the underlying cost reduction. And in fact, if you think about, I think you can use this equation here to sort of predict the likely cost reduction in the industry. And to me, it suggests that cost reduction is going to be quite a bit lower than the 15% that the industry's enjoyed for some time.
Absolutely. There are several factors when it goes to these cost reductions. Layers is one of them, and there are other innovations.
Brownfield versus greenfield, your factory, your power, all of the real-world pragmatics.
Pragmatic.
But the underlying technology curve is pretty clear.
Exactly, Rob.
Okay, Adarsh, thank you for doing that. Thank you for doing almost no economic buzzwords there, but if there are any folks that do want to talk about the economics of NAND, we're open for that conversation. Adarsh is doing some very interesting proposals in terms of building industry consortia around this topic, and I'd love to have you a part of that.
All right, thank you, Rob. Thank you.
So I'm going to echo the statements of some of my colleagues from earlier today. Fundamentally, what is this implication of the new era of NAND? Well, one of the implications is that we're going to build nodal migration around the needs of the technology from a performance and scale standpoint, not on this sort of old model. What was the old model? The old model was, well, look, I can put capital in, drive costs down, and elasticity will take care of the rest. In the new model, we need to say, well, what's going to be the demand for a given node, and is it worth us to put the capital against that node? That leads to this idea of premium nodes for premium use cases. NAND's a very strange industry. Every 18 months, we build a product. That product is faster, it's higher capacity, and it's lower power. And the expectation is we price that product below the previous generation product. Well, that's really coming to an end. So you're going to see these premium products on the premium nodes. If you're a NAND planner, if you're purchasing, if you're an operations type person, it means you need to be more thoughtful about which nodes that you consume for what applications. If you have a cost-sensitive application, taking a page from the semi industry, you're probably going to be on an older node. If you have a performance, capacity, power-sensitive application, you're going to be in the right technology swim lane. And so that premium nodes for premium use cases means strengthened supplier and customer partnerships are required. In fact, we're already seeing, this has happened in DRAM for a while, where customer contractual commitments have been moving past the single quarter pricing dynamic to now a multi-quarter pricing, and annual contract agreements where we have more certainty before we put the capital investment in that the business is going to be there. So that's a bit on the market dynamics. And that might have been a bit of a doom and gloom story, but we think it's much, much brighter. So the new era of NAND fundamentally unlocks our R&D resources and our innovation resources to focus on what matters for these new applications. We've already talked a lot about that today, of the specific needs of AI. But what the fact of the matter is essentially every single important technology in the world today runs on NAND or runs on flash. Whether it's connected cars or VR headsets or mobile devices, clients, data centers, AI, the whole world is running on flash today. And by and large, from an industry perspective, we've taken a bit of a one-size-fits-all view towards serving that market. Well, that, again, is starting to come to an end. As the different needs of these different markets start to bifurcate, the role of NAND suppliers in addressing these becomes much more interesting, because now we can start to innovate for the specific applications of the different use cases. You've heard this story already today, and I'm actually glad, because it says that as an industry we're converging around this idea that there's a specific set of capabilities that are going to matter. Performance, capacity, power. I think earlier Solidigm added features to that list. And again, if you're a student of the industry, this is not surprising. Right? This is exactly what happened in DRAM. As DRAM nodes slowed down, you, of course, continue to have DDR providing capacity. You then added LPDDR to provide for power-optimized applications, and then you added graphics DRAM and ultimately HBM for performance applications. Well, we think basically the same thing is happening in NAND, and you're already seeing that even at a die level, that 2 terabyte QLC die that we have in BiCS8, it's an awesome, awesome die, but it's not going to be awesome for everybody. It's not going to be awesome for a low capacity, low power application. So increased proliferation is going to be the technology trend to watch for. And talk a little bit about that, I'd like to invite up Khurram. Khurram, come on up.
Hi, Rob.
Great. Now, Khurram, as a system designer, how do you start to think about the role of these different capabilities in the platforms that you build?
Yeah, so Rob, like you mentioned, obviously the NAND bit scaling cost and the capital efficiencies are not the only consideration. And as the earlier speakers talked about optimizing around performance, capacity, and power, we are incorporating those into our system design thinkings. And really, it's defined by the applications, the customer use cases. For example, on performance, when we are thinking about it, all of you have heard about today The GPUs, the CPUs are really hungry for the data. You don't want to throttle them. So how do we think about performance is a key innovation vector in our technology. Similarly, on capacity, as there is insatiable demand on the data centers with respect to large capacity, specifically taking advantage of the logical scaling of QLC, we see that plenty of innovation around capacity, specifically around QLC, not only provides the cost advantage, but also provides better gigabyte per watt efficiency.
Now, I know you're really excited about a new product you just shipped into the client market, right?
Yes. So this is the DRAM-less 4-channel QLC device that is doing quite well. And this exemplifies what we've been talking around the innovation vectors of performance, capacity, and power. Really, we have our own vertical integration where we are optimizing around our controller, the firmware, and really trying to deploy IPs like read algorithm enhancements, smart caching, data path optimization, really these sorts of things around performance, power, and capacity, really giving us the experience of the TLC-like drive, but in the QLC, and it's really doing well.
Now, I think this chart over on the right, to me, was a super interesting chart because people always are concerned about QLC performance and capability, but those numbers there are the QLC device's performance relative to the prior generation TLC.
Right. That's right. And this is really optimizing around the controller and firmware. Like I said, some of these advanced algorithms really help bring the experience, TLC-like experience on our core.
So when you go from a BiCS5 mainstream client device to this QLC client device, you're going to see performance on all dimensions.
Absolutely. Absolutely. In the performance and value similar, you'll definitely see a stark improvement in both performance and power.
Now, you heard from Kioxia this morning, our partner, about BiCS8. We're super excited about BiCS8. The 2 terabit QLC die is one of the feature devices in BiCS8, although we'll have multiple die options for different applications. That 2 terabit allows you to jam 4 terabytes into a single package, and you can build all kinds of interesting things from the fantastic AI systems that everybody has been talking about to things like that 4 terabyte SanDisk card down the right. Now, I would think as a system designer, BiCS8 is going to be pretty attractive.
It's one of the most exciting technology. It's the state-of-the-art technology that's optimized around cost, power, and performance. We've got some interesting design. But really, again, going back to as an industry, this die solves a lot of problems when it comes to capacity and performance. It's the state-of-the-art, and we have some really good products cooking up with this technology. And we believe that when you look at these power and performance numbers, it's really hitting it like a Gen 9 BiCS NAND.
Yeah, so I think that's, we talked earlier about, the Inoue-san talked about the CBA technology. So that's with a CMOS array underneath that BiCS8 array. What does that allow us to do? We can fabricate that CMOS CBA wafer separately from the BiCS array. That means CMOS performance is all of a sudden detached from wafer performance. So that allows for a whole set of new use cases and interesting opportunities to proliferate. It's kind of similar to what you heard from Samsung and HBM with like a base die, a base logic die that can change independent of the array. So we think BiCS8 is going to be awesome. We're hard at work, and we'll be talking to the market a little bit later this year about some new products. Well, thank you so much, Karan.
All right, thanks, Rob.
Okay, so I'm going to talk to you next about this thing called AI. All right, I'm going to try to do this without being too redundant to the rest of the day. We had an opportunity to go out to the market early this year and really frame the storage opportunity in AI. And we used this concept called the AI data cycle. While we came up with it, we don't view it as proprietary. We think it's a way for the industry to represent how storage is being consumed in AI. To the point of the speakers earlier today, storage was a bit of a late arriver to AI, but when it came on the scene, it's really come on with a bang. And I know all of us are seeing huge upsides right now in demand, particularly across the enterprise portfolio, but also elsewhere, purely driven off of AI. And it's helpful for us to explain to the rest of the world what's going on. And fundamentally what is happening is the AI is the best thing could have possibly ever happened for the storage industry. Because what does AI do? It consumes storage, right? Storage and data is the fuel for AI, and that data is provided by the underlying storage infrastructure. And what else does AI do? Well, it produces data. And so that virtuous circle of data consumption and data generation, and then all the services that go around with that is just an amazing tailwind for the industry right now. A lot of us had like maybe a simplistic idea of what AI looks like. You have like a GPU and some DRAM and so on. That's a good high school model of AI. True AI systems are now massive in scale, multiple data centers, multiple geographies, hundreds of thousands of systems, like enormous computational complexes. And there's basically 6 stages in that AI data cycle, and each of those stages consumes storage in a somewhat different way. Starts with raw content archives and content storage in HDD. Our customers are, all that core content, all the world's data and information is stored in hard drives. Our customers are telling us when they train their AI systems, they're keeping all of that data around for audit and for compliance reasons. So you're just creating more copies and driving more demand for HDD. However, those HDD systems just aren't fast enough to do data preparation and ingestion. That's that phase 2. So for those of you that kind of grew up like me 30 years ago through this, you probably remember ETL for databases, right? Extract, transform, and load. Well, in the AI world, there's something similar. Things like vectorization, where I'm taking some big corpus of text or a video, and I got to convert it to a format that my AI training models can consume. All of that is running on top of fast data lakes. Those fast data lakes are getting powered by these 30, 60, 128, 256 gig drives that we're all talking about. The 3rd stage, 4th stage, 5th stage, AI model training, interface prompting, interfacing itself. This is where those high performance drives come into place, like their PCI Gen 5 drives. Again, all kinds of interesting use cases. Just feeding the GPU, you don't want to starve those GPUs. Checkpointing, making sure that you don't lose your job in the middle of a multi-day, multi-$100 million training. Special applications like retrieval augmented generation, the RAG applications you heard about earlier, all of those are consuming typically compute drives, using that data lake for storage and archival purposes. And then finally, that inference, of course, is happening not just in the data center, but out in the edge. Tremendous work going on in both AI for mobile as well as AI for PCs. We actually see even more momentum in the mobile world right now because the applications are so obvious, whether it's video, it's audio, it's translation, it's filters, it's social, all kinds of awesome applications. In the PC world, there's a storming and norming process going on. So from an inference perspective, driving demand across the workloads. And that new content generation, completing that virtuous circle and ending up back in archival stores and driving capacity for the future. Now, we've been hard at work building a AI-specific portfolio to address this opportunity. And to talk more about that, I'd like to invite Rizwan Ahmed, who leads our eSSD efforts. Come on out, Rizwan.
Thanks, Rob.
All right, so let's double click on what these systems actually need.
Yes, so what we observe right now, there are 2 classes of SSDs are needed. And you talked about the AI pipelines. So what we see for essentially for training and inference, you need highest performance compute SSD. And then for ingest, data prep, and checkpoint, you need high capacity SSDs. So the key driver for training and inference is the motivation there is to keep the GPU utilized. So we need the highest performance from the SSD, and to that extent, we are already using PCI Gen 5, and in very near future, we're going to go to PCI Gen 6. And then the benchmark that we really cared about is, first of all, we need the random performance. Specifically, the random read is the most important metric. And there's an emerging benchmark called MLPerf storage benchmark that essentially indicates how fast storage moves the data to training. So that will be another key.
Well, I see this is kind of a good news, bad news story here, and I think that bottom right benchmark is really the one to follow, which is, are you keeping the GPU busy?
That's right. So first of all, I am very excited about introducing our SN861. This is our PCIe Gen 5 product, purpose-built for training and inference. So this product, we have multiple form factors from U.2, E1.S, and E3.S. And so when it comes to performance, you can see on the random performance, it's actually market leading right now. And then when you run the MLPerf, the idea here is using one SN861. We are keeping one H100 GPU over 99% utilized, and two GPUs over 98% utilized. So, and where the acceptable score is roughly about 90%. So this is fantastic.
That's a great benchmark.
Yes. So moving on to the other stages that we talked about, specifically for the ingest and data prep and checkpointing, what you really need is a high-capacity SSDs. And that's because it's going after the fast data lake, where you're trying to replace object storage based on HDD, and capacity is the key driver for there. And we are very pleased to offer our SN655 up to 60 terabyte capacity. This fits very, very well for this segment. And we have two form factors here. What your market really needs is U.2 and E1.L. The other innovation that we have done there is for checkpointing. Checkpointing happens to be very write intensive, so we actually increase the endurance to make it more efficient. In terms of the product, we're already sampling up to 60 terabyte, and we're going one step beyond. Next year, we're going to have 128 terabyte capacity. And we're not stopping there. We have a long-term roadmap to take it to petabyte scale.
Yeah, I think that's the awesome thing. These are super exciting products, but the AI benchmark is moving forward, right? Yes. GPUs are going to get faster, training sets are getting bigger, and so there's a bright future here for AI platforms.
All right, thank you.
Super, thank you. AI is having a huge impact at the edge. We have the good fortune of being the leading provider of edge-based devices. So if you take and you look at the sectors that we're via our SanDisk portfolio, we sell to over 200 million consumers every year. And then, of course, broad exposure across the OEM worlds between auto, client, mobile, and the sectors that are consuming AI at the edge. What customers are telling us is that those AI-equipped and AI-powered devices are experiencing explosive growth in need for capacity. If you look at what's happening in automotive, as soon as the conversation moves to self-driving, you then all of a sudden you're in the position where you're archiving HD video coming off that vehicle. You're filling up a drive every day per vehicle. You're filling up data centers. The AI complex behind a modern self-driving vehicle typically is a 4 to 5 exabyte type of investment. So huge complex behind it. And out at the edge, more demanding compute, more demanding infrastructure as a result in all those devices streaming in. From a client side, what do AI clients want? They want bigger and faster devices. So we're focused on driving device capacities up. 4 terabyte, 8 terabyte devices, PCIe Gen 5 performance, bringing really modern, high performance systems to client devices at the edge. WD Black is our brand for our consumer client devices at the edge, and it's really shown there's a huge demand, a huge level of interest in that creator community and the prosumers and all sorts of high-end users to make sure that they have the utmost power out at the edge. Love to see you dive into these products. And in fact, in our booth, we're showcasing innovation across all of the sectors of our portfolio, data center, client, automotive, platforms, consumers, tons of technologies to talk about that we're excited to host you. Finally, before I bring Jay back out, I'd like to wrap up with just some comments about the role that Western Digital and the role that the new flash company plans to play in the industry. Now, we view ourselves as the only pure play supplier in flash. We 100% focused on this business, 100% focused on this industry, and are looking to expand our portfolio of partnerships, broaden our supplier relationships, broaden our engagement with the industry. So definitely seek us out. We're open for business, and we're looking forward to a bright future and sharing more of that future with you later this year as we go through our separation process. So with that, thank you very much. And Jay, you're going to bring us home.